The importance and nuances of pro audio power amplifying, protection, and limiting is often overlooked by even the most well-known manufacturers. When I first started in pro audio, amplifiers didn't have protection. We didn't have processors and things. And the ones that did have protection, they were even using over-easy limiting. Over-easy limiting makes something sound bad at lower volumes before not protecting it properly at higher volumes. It wasn't until the Meyer MSL3 came in with that processor that the audio industry realized the importance of protecting the speakers with a dedicated processor or dedicated settings. Having processors that were precisely set for the dedicated loudspeakers revolutionized the pro audio industry. Before that, you would just pretty much have to know where the amps are clipping. Someone would tap you, hey, the amps are clipping, you gotta turn this down. You're constantly trying to run the system such that you didn't overload, and if something went wrong, poof, you blew out a whole bunch of speakers. All of a sudden, something comes along where everything is protected. It seems so obvious now, but this was not always the case. Having dedicated system processors allows us to use smaller systems at higher levels with higher quality audio. If you're operating a sound system and you're not hitting the limiters, maybe you have too much PA. You've dedicated too many resources to the main sound system that could be dedicated elsewhere, or bringing in less gear out front, improving sight lines, reducing your setup time, reducing your loadout time, or maybe adding delay clusters and improving sonic consistency or level consistency throughout the venue. So the limiters allow you to operate it at the optimum level. When determining the limiter settings for multi-way systems, you're faced with this choice. Do you set the limiters for maximum output levels, or do you set them to maintain tonal balance when the system is driven hard? Typically, the high frequency compression drivers of a sound system, of a pro audio sound system, have increased headroom over the low frequency, less efficient cone speakers, which means that if you were to set all the limiters at the point of destruction or protection, the lows would go into limiting first and the highs would go into limiting later. At lower volumes, you can EQ and get everything balanced, but when you push the system hard, the low end starts to limit before the highs, the system gets harsher. It could change the tonality of two kick drum beats, one hit soft and one hit harder. Or when a band ramps up and plays harder, the system gets harsh, you turn it up, it gets harsh, you turn it down, it becomes less harsh. This may not be desirable, but it allows you to get maximum levels. The other way to go about it is to set the limiters such that whatever band, the lows, mids, or highs, goes into limiting first, the other bands also go into limiting to try and maintain a tonal balance of the system at low, mid, and high levels so that it doesn't change with level. And you'll experience both of these things as you use various systems from different manufacturers. All right, so let's dive in and take a listen to the limiter approach for L-Acoustics and D&B. I've got two amplifiers here, an LA12X and a D&B D80, and we're gonna listen to the output of the amplifiers. So we're gonna put I'll put various signals into the amps, and that'll run into this load bank here. And I've got a 0.1 ohm 50 watt resistor in line with one of the output wires. And we're gonna put two wires across that. We're gonna lay across that, go into a small audio transformer and into this mixing board over here. And we'll listen to the voltage drop across that resistor, which will allow us to hear the output of the amplifier. We'll be able to listen to what the L-Acoustics sounds like, driven at full volume, driven at low volume, driven hard into limiting, and the same for the D&B. And it's really kind of cool. You can do this, you can just take some 0.1 ohm resistors and build a speaker cable that's cut your 1 minus and 2 minus lines, insert these resistors, have some wires go to pin 2 and 3 of an XLR into a transformer, into a mixing board, and you'd be able to listen to the output of your amplifiers or record the output of your amplifiers during a show to a portable recorder and listen to them later when you're looking for faults or if you just want to hear what's going on. It's really a neat way of doing it. Also, this 1/2-inch metal plate is going to get hot. I've got a lot of resistors on the back of this. We're going to be driving a lot of watts. I had to power tap the AC panel of my house in order to get enough juice because I kept blowing breakers doing this test. And I think the easiest way to do this is going to be put in a circuit breaker. This is only 20 amps, but it should be enough to handle it. Did you know that there are metric flathead screwdrivers as well as imperial? The width, the thickness of the blade is in millimeters instead of inches, and the metric version is a little fatter than the imperial version, and sometimes it won't fit. You have to use a narrower blade in some situations. This one is one of those situations where it barely fits, but it's good enough. Cool. All right, we're live. So we've got our thermal detection egg here that will allow us to determine if the load is getting too hot, because I don't want to blow it up. So we'll be utilizing that along with some thermal lubricant. It's yellow. Okay, so safety first. Let's get our thermal protection. There we go. Oh, I forgot to use the thermal lubricant. All right, so let's go ahead and give a listen. I've got the L-Acoustics LA12X amp with a KS28 100 Hertz setting. And I've got the DMB D80 with an SL sub, not infra setting. So this is set up for a double 18. This is a triple 21 with the rear 21 being cardioid. We're going to listen to the front 21 signal. And these are the kind of the primary current subs for these two manufacturers, stuff that you'll run into on the upper levels of Pro Audio. So we'll give that a listen, and I'll bring this to a low volume. And that's the L-Acoustics amp, and we'll go to the DMB amp. And they do sound a bit different. I mean, this is a signal for a double 18, this is a signal for a triple 21. The cabinets are designed different, but we have two similar sounds, let's say. Now let's go ahead and bring this up. We'll go back to the L-Acoustics, and we'll listen to what happens to it as we increase the volume. And we can see it on the meter there. There's limiting. Now we're driving really hard into limiting. And you can hear the tonality of it change. Switch to the DMB. All right, let's drive it even harder. And the L-Acoustics. And you can hear some nuances. If you have headphones, you have a kind of a bigger stereo, you can hear poof. You hear that limiter bouncing, coming back up on the L-Acoustics. And on the D80, it's kind of grabbing it quicker. But in order to hear the limiter setting a little better, let's use a tone in addition to the pulse. So let's bring that up. And this is a 60 Hertz tone. And we'll start to bring up that pulse. And this is on the L-Acoustics. We can compare the two, L-Acoustics, DMB, L-Acoustics. So if you listen to the tone, you can hear it go pop. It's pushing down everything, and there's a recovery time to it. Let's switch to the DMB. A much faster recovery time. Two different approaches. Let's go ahead and interesting. So the L-Acoustics has kind of got a longer term, pulls down, it maintains more of an even sound. The DMB really kind of grabs that pulse but leaves the low end intact. It's just, which of those is better? Different results, different sounds occurring. Cool. Let's do the infra mode on the DMB amp, which kind of equates more to the KS28 60 Hertz setting. So now we'll compare infra. So let's start with the pulse. L-Acoustics. DMB. Tone. Okay, we'll bring the pulse way up. Tone up first. Interesting. Okay, so again, we have that kind of steady tone with the kick drum being, or the pulse being pulled out. And it's tilted the sound more towards the bass guitar player, if that's what was making the 60 Hertz tone on the DMB setup, whereas the L-Acoustics kind of maintained the integrity of the kick to bass sound, or the pulse to tone sound, and then brought the entire thing down. Two different approaches. Cool. Let's try something a little different. For this, what we're going to do is send a high-level signal to the amp and simultaneously send a low-level signal to the other channel, to another channel of the amp. And so we have a clean and dirty, and then we'll reverse a polarity and resum them and listen to purely the limiter impacts. We will take this out of polarity signal here from the clean channel. We should be able to get a null. Okay, pretty good. Let's do the same thing for the DMB amp. All right, we can listen to DMB versus L-Acoustic. All right, so now one channel of the L-Acoustics amp is driven hard. The second channel is driven very soft. And the same thing with the DMB. So we have, as we bring this up, one channel will go into limiting, the other won't. And we've known these against each other below limiting. Let's listen to what these limiters sound like, and let's see what they're doing. So we'll start with the L-Acoustics. And we're hearing what's being taken away. And let's bring up this. And let's listen to the same thing. So we can hear the tone coming up in volume as it's being limited. Let's go ahead and listen to the DMB. Again, like we heard before, the tone's not being impacted as much. All right, looks like our thermal indicator is working as it should. All right, so our thermal indicator is doing well. I flipped the egg over, and let's check out an X15, which is an L-Acoustics 15-inch two-way versus a DMB M4, which is their 15-inch two-way, and we'll listen to those settings. And we'll start with the low end of the L-Acoustics, below limiting, and we'll go to the DMB. L-Acoustics definitely has a bit more low end to it. And the DMB has the 15 going up higher, which is kind of interesting. Separate limiters. Listen to the horns, L-Acoustic, and DMB. Listen to that. The horn on the DMB is being run down to a much lower frequency. Much higher crossover on the L-Acoustics. But that's beside the point. Let's see what the limiters are doing. So I'm going to turn the lows and highs on together for the L-Acoustics. And we'll bring it up into limiting. Yeah, almost like an echo. Pulling back and returning. Really beat it up good. And let's compare that to DMB. It's a completely different sound. It's almost like the DMB is limiting the low frequencies more than the highs. It's kind of gone to a mid-range boxy sound. And the L-Acoustics didn't. Let's bring this down and listen to a lower volume. So tonal integrity, DMB, low getting louder. And L-Acoustics, low getting louder. Vastly different limiting strategies. DMB is kind of going for max volume. L-Acoustics is looking for tonal integrity throughout the volume range. We could try an M2 over here real quick, and it looks like our thermal indicator is just about done and letting us know that we have finished the session. Back to the L-Acoustics. And M2. Now, there's two 12s in an M2, which is going to give it 6 dB more output. So I'm going to boost the low end on the DMB a little bit to kind of account for that second 12. Close enough. Now let's drive this into limiting. There's the L-Acoustics, really hit hard. And DMB hit hard. The DMB takes away all that low end when it hits hard. And we know, or if you've used DMB M2s, they're real punchy when they're hit hard. They're known as punchy. Limiting that low end and keeping those upper frequencies intact gives it that punch, but it changes its tonality. Try the completely different. Okay, I'll put a tone on while I'm doing that, and we'll hear how that impacts. We'll do that with the L-Acoustics. All right, with these resistors, 0.1 ohm resistors in line, going to a transformer for isolation, and then out of the 1-to-1 line transformer into a channel or recorder, you can do this. I try and do all my tests so that you can duplicate them and prove me wrong, prove me right, learn something, do it yourself. I highly recommend experimenting because you never know what you're going to figure out when you do so. This is really interesting. Setting limiters is a very delicate science, and it can make or break a product. If the limiters are set poorly and it farts or cracks, or the selection of driver is such that when driven hard, it bottoms out, makes a little farting sound, that can kill a product even if everything else is in line. Also, failure rates, maintenance costs, and the ability to deploy a smaller system covering a larger area because the system sounds good when it's in and around its limiting. All right, hope you enjoyed this, and let me know what you think. Cool, cool.